S.Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today, we are going to discuss a topic called HBase in Big Data Analytics. Let's get started. So, what is HBase? So, HBase is a distributed column-oriented database built on top of the Hadoop file system. It is an open source project and it is horizontally scalable. HBase is modeled after Google's Big Table, which is generally known as a distributed storage system for structured data. Apache HBase provides Big Table-like capabilities on top of Hadoop and HDFS. Some of the companies that uses HBase as their core program are Facebook, Netflix, Yahoo, Hadoop and Twitter. So what is the goal of the HBase? The goal of the HBase is to host large table with billions of rows and columns on top of clusters of commodity hardware. We all know what is commodity hardware. The next one, the HBase is the main part of the Hadoop ecosystem that provides random real-time read-write access to data in the Hadoop.
Hello, this is Lavanya. I would like to discuss a fundamental aspect of big data landscape, that is HBase or Hadoop database. Hadoop database or HBase runs on the top of HDFS, that is Hadoop distributed file system. These are all part of Hadoop ecosystem. HBase is a column-oriented, non-relational database and it is horizontally scalable and it is a fault-tolerant database. It stores billions and millions of rows and columns. Let us know about the Hadoop architecture. Hadoop architecture has three major components: Zookeeper, Region Server, and the most important part is HMaster. HMaster in HBase architecture works like a master and it monitors all the region servers and also controls the load balance, and it assigns regions to the region server as well as it allows DDL operations. If we come to the region server, the H tables are divided horizontally into regions. Regions in the region server does many activities like managing, executing and handling as well as read and write the HBase operations. If we come to the Zookeeper, which is a major component of HBase, it acts like a coordinator of HBase and it provides many services like naming, maintaining configuration information and data synchronization, and it looks after the server failure. And it is like a medium where the client can communicate with the region server via Zookeeper. At last, let's acknowledge the significance of HBase, the foundation where we build the future data-driven insights and discoveries. Thank you.
Now let's see the features of HBase. HBase has a number of features like it is scalable. We all know what is scalable. HBase allows data to be scaled across various nodes as it is stored in HDFS. It provides automatic failure support and also provides consistent read and write of data. The HBase also provides ease of use to Java API for client access, and also it supports block catch and Bloom filters for high volume query optimization. Now let's see the architecture. So the HBase architecture has the following important main components. The first one being the Apache Zookeeper, which monitors the system. HBase Master, it assigns regions and it load balances everything. The region server, it serves data to read and write. The read and server is all the different computers in the Hadoop cluster. It consists of region, HLog, store, memstore and all other different files. It forms the main component of the HDFS storage system. Now let's have a look at the HBase architecture. So first one being the regions. So regions are nothing but the regions are HBase tables which are divided horizontally by row key range into regions. Regions are assigned to the nodes in the cluster called region server. These servers serve data for reading and writing. A table can be divided into a number of regions. A region is shorted a range of rows storing data between a start key and an end key. A region has a default size of 256 megabytes, which is again configurable. A group of regions is served to the clients by a region server. At most it can serve up to 1000 regions to the client. The next one we'll see HMaster. So HMaster handles a collection of region servers which resides on data node. It performs DDL operations and assigns regions to the region server, as we can see in the image. It coordinates and manages the region server similar to the name node as we have seen in HDFS. It assigns regions to the region servers on startup and reassigns regions to region server during recovery and load balancing. It monitors the region servers instances in the cluster. It also provides an interface for creating, deleting and updating files. The next one will be the zookeeper. So the zookeeper acts like the coordinator inside the HBase distributed environment. It helps in maintaining server state inside the cluster by communicating through different sessions. Every region server along with HMaster sends continuous heartbeat at regular intervals to the zookeeper, and it checks which server is alive and available as mentioned in the image. It also provides server failure notification so that recovery missions can be executed. Referring from the above image, we can see there is an inactive server which acts as a backup for the active server. If the active server fails, it comes for the rescue operation. The active HMaster sends continuous heartbeats to the zookeeper, while the inactive HMaster listens for the notification sent by active HMaster. If the active HMaster fails to send a heartbeat, the session is deleted and the inactive HMaster becomes an active one. While if a region server fails to send a heartbeat, the session is expired and all listeners will be notified about the error message. The next one will be the meta table. So the meta table is a special HBase catalog table. It maintains a list of all region servers in the HBase storage system. Meta file maintains the table in the form of keys and values. Key represents the start key of the regions and its ID, whereas the value contains the path of the region server. The components of region server are WAL, as you can conclude from the above image itself. Write ahead log is a file attached to every region server inside the distributed environment. The write ahead log stores the new data that hasn't been persisted or committed to the permanent storage. It is used in case of failures to recover the data set. The next one is the block cache. So from the above image, it is clearly visible that the block cache resides in the top of region server. It stores the frequently read data in the memory. The next one is memstore. It is the write cache. It stores all the incoming data before committing it to the disk or to the permanent memory. H file from the above figure, we all know that it is stored on HDFS, that it stores the actual cells on the disk. Memstore commits the data to H file when the size of the memstore exceeds.